So I guess one of my questions is I've been investing a long time, many years, but I know that this all started many years even before that. So my question for you, Eric, is I know you were originally in cosmology and interested in plasma cosmology. What got you interested in the smaller scale that the dense plasma focus has?
Right. Well, it it really was kind of simultaneous. So, you know, I had been interested in fusion. My interest in fusion is pretty much coincident with my interest in science. So, my father was a scientist. He was a analytical chemist working most of his life for the United States Customs, and he ended up in charge of the customs lab. And so there was science in the household. But when I was 8 years old, my mother bought me a science for kids books about the sun. And I remember at the time being struck by this illustration of the enormous energy being generated by the sun. And they illustrated it by this um, endless railway train carrying coal. And they were saying, in a single second, the sun generates as much power as, I don't remember exactly, a railway train that would reach from here to the moon or something like that. So very early on, I was interested in fusion. Um, and uh, in 1960, when I was 13, the laser was invented, and this was very widely publicized. And many, many people pointed out, gee, this intense source of light and heat, maybe this could be the trigger for fusion reactions. So I was very interested in it all through high school and college. But I had thought, because the tokamak had been so publicized while I was in college, that maybe this problem has been solved and it's not something I'm going to be professionally interested in. But shortly after college, in the early 1970s, I met two of the pioneers in this dense plasma focus, which were Victoria Nardi and Winston Bostic, who were both local. I was living in New York City, and they were local at Stevens Institute in New Jersey. So they said, no, 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 the tokamak's not going to work. And this is a very interesting device because, and many of you have heard us say this as a slogan, because we use the instabilities, we don't try and fight them. So I got interested in that. I'd long been interested in astronomy. And basically, in the late 1970s, I started to think about the tiny plasmoid in the DPF, which I was by then pretty familiar with, as a model for quasars, which had just been discovered to be emitting these huge beams. So pretty much from the start, the cosmology and the DPF were connected. So that's really the start of my professional research, was back in 1980, and I started publishing in both fields in the 1980s.
So another question, do you all have a succession plan? Um, it's no problem if we get to uh, net production of uh, energy in 2 years, but what about 5 or 10 years? We have a continuity plan for the research?
Well, in formal terms, the leadership of the company, if something happens to me, goes to Ivy. Obviously, we're a very tiny team. The full-time people are Ivy, me, and Dr. Syed Hassan. So obviously, we're not kidding. We can't afford to lose anybody. We don't really think it's going to be another 5 years. I know that we have in the past, like many other people in the fusion field, been overly optimistic, but we now are working with our final fuel with hydrogen boron. And I'm pretty optimistic that, this will be the year we reach net energy. And once we reach net energy, we are going to transition, given funding, to a much larger project with, 100, 150 researchers, where the leadership will really be in a team of engineers. Obviously, we'll still be contributing. So the question of succession will be much less vital. But fortunately, we're all in good health right now. So I think that the risks that one of us is going to drop dead before we get to net energy is pretty small. It's the greater risk is that we, make some detour, uh, and I don't think that that's going to be happening.
I just want to say I'm so glad to finally meet you, Walter. I've never actually seen you. I know we've been working together for almost 7 years, as far as I remember. So pleased to see you finally.
So, Walter, I have a question for you, which is pretty similar. Um, when did you first invest and why?
Walter
Okay,
is
yeah. So I think it was something around 2012. My wife and I went to a Mars Society meeting, and one of your collaborators, I think named Derek, I might have that wrong by this time,
No, that's true.
gave a fascinating hour-long talk about the DPF, and I took him to lunch afterwards to um, pick his mind more about it because I'm in a very amateur way interested in physics. Um, and everything he said was very exciting, and it led me to um, read some of what you had published on the DPF. And I invested for three reasons. First of all, if you get to where we can produce electricity from fusion, obviously it's a huge return on investment, but also just as far as supporting basic scientific research, I feel like this is important and interesting. And the last reason was that unlike many startups, um, you had a plan B, which involved using the DPF as a X-ray generator for examining infrastructure, which in and of itself would be huge and certainly would produce a return on investment. Um, and I've been following your progress. And the most exciting thing, of course, is when you um, are able to confirm one of the predictions that's come from your theory about how the DPF works, because that really supports the validity of the theory.
And when was your last investment? And why are you still investing?
Oh, well, it was just recently $780 more to push you over. I think the $250,000 mark. So I invested a few hours before midnight. I've forgotten what it was, just for the fun of helping you reach that goal. And the continued investment is, I feel good about because of your continued progress. So many startups, they talk a big line, they show you a bunch of plans that they have, but over the course of 2 or 3 years, they don't really make any concrete progress, although they continue to raise investments, but it doesn't really seem to move them closer to their goal. And LPP has dribbled out over the years a steady stream of progress, additional published papers, and it's clear to me that you're really heading, incremental though it is, towards a conclusion here. I guess one of the other things I'd like to ask you too, Eric, is in the history of Nobel Prizes, it's frequent that the Nobel Prize is awarded years or decades after the discovery. I think the Higgs Nobel was awarded something like 50 years after the paper was published. If you do reach net um, energy this year, how long do you think it'll be before you get your prize on the wall?
Well,
Because that's a no-brainer.
right. Well, I mean, I think um, the rewards of our team developing the next energy source for humanity are, I would say, pretty much bigger than the Nobel Prize. Um, that's, uh, but well, I won't say anything more about that. Um, did you want to ask a question of Ivy, Walter?
No, I think Ivy's doing a fantastic job, so just keep it up.
I
We
can only
think
say
so.
I'm bringing new people in as much as I can, including people who never knew what fusion was. And they are showing a lot of really meaningful support because once they understand what the hell we're doing, they're writing amazing skits and sketches that my other friends can actually act out and bring in the newbies who, watch those fancy Hollywood movies with fusion happening and they don't understand what's actually happening in the movie. And that's one of the big um, things we want to do in the future to actually just do commentary on these crazy Hollywood movies, which, by the way, always present fusion in all the possible wrong ways and never the correct way. So there is so much opportunity to, number one, inspire people, give people hope, show them what's possible and how and why. So the newcomers, they help me do that. And then the guys who are already in the know, like you, that's where it matters when it comes to actually bringing in the money from those who actually want to support the research. But we're trying to hit everybody across the scale, from beginners to the pros, which is why some of our videos, like the last one I suggested in the invitation for the Zoom, are pretty high there scientifically. I mean, you have to understand why is the number of rotations of plasma limited on all scale levels, from galaxies to the lab device. So that's what I'm dealing with. I do have a question though. How involved is your wife in helping our project?
She's very supportive of me and the project. I do get obsessively talkative about it sometimes when you all make real progress. And fortunately, she's interested enough in these things to follow along and be excited about it herself.
Great, great. Glad to see. I certainly am not sure from which angle to bring more females. So if anybody has any suggestions, please let us know later in Q&A session.
Yeah, just for background, at the moment, our investors are still running about 6% women and 94% men. So that uh, maybe it's down to, it may be up as high as 8 or 9%, but obviously it's still very disproportionate. So this is something we're looking for. Um, Ivy, was Sam going to be ready for a brief comment on?
Okay, yeah. So one of the things we want to let everybody know is that one of our biggest fans, 29-year-old New Yorker, has been helping us. Actually, he's been subbing me on Fridays, starting sometime last year. He's been helping in the lab, but he's also a web designer. And as I said, he's a fan and he actually understands everything we do. So he came up with a big new thing, which he calls Billionaire's Hope. What is it? Let me put him on the screen and then he can tell us more.
Okay, let's unmute Sam.
Sam, you can unmute yourself. And let's see.
Let him get on the screen.
Hi, everyone.
I,
I'm Sam. Nice to meet you.
Hi, we don't see you. We just see your picture.
I don't think I'm allowed to turn on my video.
Oh,
Oh,
hi.
yeah, there I go.
Hi.
Hello, everyone. I'm Sam. Um, yeah, well, yeah, so I've been working with LPP for a few years now, kind of doing a little bit of everything, helping in the lab, helping with the site, and then um, importantly on this topic, like on outreach, and we're thinking about new ways to branch out into new audiences because I think we have a strong core audience. Like everyone on this call, a lot of people on the YouTube, but there's so many more people that we could be reaching. There's a lot of people who fusion is kind of an unfamiliar and intimidating topic for. I mean, I think even science in general is an intimidating topic for a lot of people. Um, but we believe that the work that we're doing is, I mean, incredibly important and incredibly relevant to the world today and to kind of moving humanity forward. And people should be talking about it as much as they talk about other stuff in the news. So, yeah, I had this idea for starting basically like a fusion fan club, one called the Billionaire Hope Club, which we'll be seeing more of potentially in the next month or two. So look out for it. It'll be kind of um, our post fundraise push towards
We
our
will.
next goal.
We will share the progress. Just a few days ago, we had actually connected a donation app from the site to one of our local credit union banks, where we actually should be able to get like good 5% interest rate. So things are happening in the background, but just not fast enough.
I just want to, you should explain, Sam, just the name, what the concept is about billionaire.
Mhm.
Oh, sure. So my idea is that um, being billionaire is not just about money. Like it's not just about wealth, right? It's not about having $1 billion. It's about being free, like free to do the things you want because money is no object for you. So what if you could have that freedom without needing $1 billion? What if you could have it just by things being affordable in life, by energy being so cheap that it makes everything else so cheap that we don't have to work as much, you don't need as much money to get by and do the things you love. So you experience that same kind of like billionaire freedom, um, but through the power of our technology.
Right.
Um, yeah.
That's great. Okay, so before we start the general question and answer, I do want to just give a little more background on the state of our outreach, the audience that we're reaching. So for people who are not on WeFunder, many of you are not, we are just approaching $400,000. Our goal is 500,000. We may or may not reach that because we've only got 5 days left, but we've gotten that from about 300 investors. Now, the other end of the funnel, we're reaching out to about 20,000 people on YouTube. So that's our biggest audience. Those are the followers of our channel. And the followers on WeFunder are about 4,000. And of those, about 2,200 are investors. Now, so obviously, of those audiences, only a small fraction have invested this year. So part of our effort is how to convince people to invest. And that's sort of what I'd like maybe some of the questions to address is what does it take to convince any of you to invest right now? Because that's one of the things we're curious about. So, any further comments, Walter or Ivy?
Yeah, I think maybe Hugh wants to tell us a little bit about his sketch that he wrote because I think he hit a lot of connecting points. So let's hear from Hugh about how he got to write his funny skit, which we will share. Right now, it's still in production. We got the latest script with prompts for AI, if I ever get to do that, since we can't afford the actual actors. Okay, so ask to unmute Hugh.
Hey, can you hear me?
We can hear you and
Now we can see you.
Hi.
Okay.
Well, I wasn't expecting to
Uh-oh.
speak up. I guess I will. It's exciting.
Now, wait a minute.
I think I'm
Juan, can
being
we
given
fix
this.
this? You,
The sound is breaking a
the
bit.
sound is totally broken.
Oh,
Um,
really?
Can we fix that?
yeah, keep talking.
Oh, can you hear me? Am I
Yes, we
okay?
can hear you now.
Now it's
Yeah.
fine.
Okay,
Yes.
Go
strange.
ahead.
Okay. Yeah, so I wasn't expecting to speak right now at all. I just wore this tie just in case you put me on the spot, so I'm glad that I wore the tie. But thanks, Ivy, for introducing me. I think I'm being handed this grenade right now to speak because I'm the newest person here. And honestly, the least technical when it comes to fusion. So I do consider this a form of hazing, by the way, that you're giving me this right now to speak. So usually kind of like that lack of knowledge, that's not something that I brag about, but I think in this case, it gives me, the advantage of being close to the audience of the target audience. It gives me the advantage of being able to see fusion the way that most people would. And I think that's a gap that we need to close. So I guess I'll just link it to, like the fundraising. I think part of our ability to raise more capital will hinge on how effectively we make fusion relatable, and that's the direction that I'm going to try to help us lean into. So now, just to let you know where I'm coming from, when I first heard about fusion many years ago, it was so dense and sounded like science fiction that I just kind of brushed it aside, like it's some kind of conspiracy theory or something crazy. It felt like one of those things where you hear it in a movie, like I mentioned. I kind of think, yeah, what that means. And just keep watching it. Like it just doesn't really, like connect with you. So the word fusion didn't mean anything to me because I didn't have the background to make sense of it. And it was only through luck that I ran into some news articles and then some science videos about fusion that I realized, hey, this is a legit thing. Like this is real tech, technology. This is the future here. And if I hadn't had that luck, I would have never tried to look further into it. Now, obviously, we can't count on everyone else to have that kind of luck. So we need to help bridge that gap with our outreach. So we need to meet people where they are, not just intellectually, but culturally. And that means demystifying the science and making it relevant and current, even aspirational. We need people to see fusion as something that belongs in the modern world right now. And as a personal philosophy, when it comes to technological advances, I've always believed that we can't launch a rocket ship without math and science. I don't think anyone here would argue with that. But we also have no reason to launch that rocket ship without the arts and humanities. At some point, everything has to work together, the math and science and the humanities. At some point, we have to be able to communicate the reason we're doing this. We have to spark people's imagination. We have to inspire hope for the future. We have to give people a story that they can see themselves in. So part of our strategy is to connect fusion to things people already understand with clear explanations, benefits, and familiar stories and references. Because when something feels understandable and culturally relevant, people are more likely to trust it, to talk about it, and eventually to invest in it. And we want folks to not just understand the technology, but to identify with our mission so that they can come along with us on our mission. We want our success to feel like their success. So by making fusion approachable and grounded, and by speaking in the language people already use, we think that we can widen the circle, build long-term interest, and ultimately bring in the support and funding this work deserves. So that's kind of my focus. I think that's kind of what I've been assigned as the newbie, even though no one really told me that. But I'm just kind of inferring that that's what you guys want me to do.
Yes,
Sounds great.
you've been a funny writer ever since I known you, and you have that ability to actually simplify the science and the benefits of fusion in such an entertaining and educational way. I just can't wait to share what we've done with our group here.
So
Okay,
hopefully
well,
you will like that because I do try to restrain myself a bit. I know that this is a more professional outfit. I try not to go too far off the cliff, but hopefully, you guys will still like it.
We're still deciding if the main characters should be a female scientist or a male scientist who is a roommate with another dude who is just a totally relaxed but funny roommate. So we're still trying to see who the characters will be, but the script is pretty much 100% ready. So stay tuned to our report and do register if you didn't register on the website homepage.
we certainly support 100% the idea that fusion needs the arts. Science needs the arts generally. That's really key.
Fabrizio, you can ask your question.
Yeah, sorry. I had to put the baby in the bed. So my name is Fabrizio. I'm a computer scientist. I work in the field of high energy physics since so many years that I forgot. And at some point I was fascinated, interested, and inspired by the LPPFusion idea, by the talks given by Eric in so many occasions, by the written papers, and so on and so forth. So I'm following the thing, and at some point I decided to invest something with the spirit of someone who gives a little contribution to something that looks interesting. However, I always had a question with respect to this. And I thank you very much for the opportunity of seeing you in the face in real time and to be able to pose this question, which is that I have the impression that the I don't know if it is the idea or LPPFusion by itself or someone. I have an impression that the initiative and the ideas are a little bit overlooked by the, let's say, bigger investors or the traditional funding agencies. And well, I always ask to myself, why? So, what's your opinion about this? Well, you can also deny, you can tell me, no, it's not true. I mean, of course, I can be wrong. This is just my impression. But anyway, the question remains. So, what's your point about it?
Right. Well, it's a good question. I mean, to rephrase it is, why don't we have big investors? Why don't we have billionaires in the terms of the dollar sign billionaires backing us while other fusion companies do? So let me start with some of my experience when at an earlier stage, when we were just setting the company in motion in the early part of the century, I actually was introduced to quite a number of people who were really high wealth individuals. I don't know whether any of them back then was actually a billionaire, but probably most of them are billionaires today. But they were certainly people who could have written a check for the entire project um, and treated it the way I would treat, oh, can you buy me a cup of coffee? Um, and we didn't get a red cent from any of them. I never made an exact count, but I'd estimate there were about 2 dozen of them that I talked to personally. Well, from those conversations, it was very clear that there were two big reasons why they weren't investing. One was they wanted control. Most of these guys, what they get out of their wealth is not necessarily what Sam's talking about. Maybe that's part of it, but what they really get out of it is a sense of power. And they like to control. They basically take it as a key criterion that they control the investment. And we've never said that that can happen. I
In fact,
mean,
we have refused millions and millions of dollars over the years because we had so many people offer that. And every time we tell them they cannot have the control, every time after we lose weeks and months on them, they still come back with, oh, but we want the control.
right, right. As Ivy says, once we set up the company, it made it clear that I couldn't even overrule the idea that me as the scientist has the controlling shares because it's built into the shareholders agreement that all of you who have invested have signed. I can only transfer the voting shares by my will. So that was one big problem. And I still think that that's the biggest. The other was many of them invest in things where they are certain they can get a return. So many of them, I remember one particularly from Italy. We were at a very nice banquet, seafood buffet outdoors. And he said, well, he leans back and he says, well, come back to me when you have a working prototype fusion generator. And I said, if I had a working prototype fusion generator, why in the world would I be asking you for money? I'd be showered with money. So that conversation in those words happened to me several
Okay, but
times.
I'm sorry to interrupt. There is another really realistic reason why this is happening and why we're the only fusion company you can go to crowdfunding platform and actually support us. No other fusion company is exposed as we are because of their corporate structure, which is owned by some billionaire or millionaire. They don't even have the platform where unaccredited investor can even join. And this is true of Helion, of TAE, of all the big players.
So I would say that those were the two big reasons. And, it was explained to me by one of these guys that a lot of them think that they could invest and simply do it as a trade. We can get into with another question the recent Trump acquisition of TAE, but a lot of financial advisors said that that didn't indicate any particular interest in fusion. It just was a way of pumping up the shares. The third and final reason is herd mentality. And again, we've heard this from very many people and read this in the financial press. Rich people, very rich, tend to invest in what others are investing in. And therefore, um, they, they sort of follow the crowd. So the fact that we have very little money is a big turnoff to these people. If somebody else hasn't invested a great deal of money, then why should they? So this herd mentality can lead to disasters such as the Madoff scheme, where he defrauded people who were very high value because their friends had been investing in Madoff, and that made it good. So those are the three big reasons. And frankly, we don't really expect it to change. I mean, and we don't need it to change. To raise the amount of money, not only for the uh, net energy scheme stage, but for the final stage, the development, which takes about $150 million, we really only need investments from small and medium investors. I mean, we're getting investments of $1,000 on average through crowdfunding. And I would guess about 10 or 20,000 on average through Reg D. Well, you run the numbers and, 10,000 investors would get us to the amount of money we need to become a profitable company with a proven product. So that's really what the direction we're going in. I would say that there are probably 10 million people in this country, minimum, who would invest if they learned about us. So it really is a question of doing those two steps, getting to many more people than we're getting to, and convincing them to invest. So I think those are the reasons why we don't have large investors. Does that answer the question?
Yes, it answers the questions in two ways. One is the way that you have addressed speaking so directly about private investors. And the other one is that you have not mentioned the public investors, which tells me that you probably never considered or was considered by them. Please remember what I started with by presenting myself. I work in the field of high energy physics, so I'm used to hear words like funding agencies. And these are not private investors, these are normally public investors. So with respect to this, I have the impression, which is not good nor bad, so just the plain impression that your approach to fusion is as original as your approach to funding. With this, again, I cannot say it is good or bad. I say just that it is as interesting.
Well, I'm sorry, I didn't understand you were addressing the government. We refer to them in the United States as government investing because, yeah, public corporation actually means a private corporation that allows the public to invest. So there's a dual story. In terms of the federal government, there is an unfortunate history. The federal government, together with major governments around the world, back 50 years ago in the 1970s, made a policy decision that they were going to go with the tokamak and the laser approach and nothing else. And that was a massively premature decision because it basically said, we know the science, we've done the science. This is an engineering project like the moonshot. And that simply wasn't true. I mean, the main motivation for saying that was to get money from the government uh, that was confronting the oil crisis of 74, and they wanted some short-term solution. So it was really a deal with the devil by purporting to say that fusion was an engineering uh, development. So right now, we just can't get money from the federal government because 50 years later, they still have the same approach. But we have tried to get money from lesser governments, from the state of New Jersey, and that's certainly a possibility. I think that if we got to net energy, I do think that we would have the very good chance of getting some of
Have to
this
go to the next
money.
person, Eric.
Yeah,
I think you may be well right, and I thank you
right.
very much again for your answers.
Okay,
Thank you,
thanks.
Fabrizio.
Okay, let's go move on to the next person.
So
Hello, Eric. How are
Patrick,
you?
Hey,
Ivy.
Patrick,
hi, how are you?
go
Hi.
ahead.
I have a, I'm a science fiction author. I think I wrote to you before about this, but in the future, I could foresee that the DPF could be used without the drift tube as a propulsion device in deep space. And I wonder if you could comment on that and what would be the resultant thrust of a system like that, exit velocity of the fusion
Right.
products. Yeah.
Thanks for that question. So our initial funding, sort of prehistoric, before we had the money to build our own device, came from NASA's Jet Propulsion Lab out in Pasadena. So this was exactly that, to use this in their advanced propulsion program. And we were funded for a couple of experiments, one at University of Illinois and the other at Texas A&M. Um, so definitely this could be used. We figured this could be used to get a mission to Mars in 2 weeks, not a year, but 2 weeks. And you could send probes zipping around the solar system. I think it would be about a month to get to Jupiter. Basically, as you say, we would put the beam out the back end, uh, and you could get significant thrust that way. If you needed more thrust, you could actually use the beam to accelerate a greater mass of material. But uh, instead of having these huge rockets, I mean, an existing chemical rocket has a mass to payload ratio of about 100 to 1. With a DPF fusion rocket, the ratio would be about 1 to 1. So yeah, we definitely write this uh, into your science fiction. Again, this is another way of merging art with science.
I'll send you the story.
Yeah,
Right.
yeah, do. Please do.
We're looking forward to it.
Okay, well, thank you. And I got a comment here that I really appreciate the work that you guys are doing. I think that this is something that's going to lift everybody's boat. And I'm an investor and I'll invest again. And if my business ever gets sold, I'll be back.
Great,
So
thanks.
good
Thank
day.
you. Thank you. We appreciate it.
Okay, thank you very much. Next question.
So there were some questions on YouTube. I'm trying to see. Well, the last question was, how do you get the excess energy to generate electricity? By Brody Love 2.
Okay. We do explain this in quite a good deal of detail on one of the Prime videos that are on our website, which I think is called How Do You Get the Energy Out? But the short answer is the energy comes in two forms. Most of it comes in the form of the ion beam, which is generated by the plasmoid. Nature gives us the beam. And if you take a beam, which is already electricity, moving charges are electricity, and you run it through basically a coil that induces current in the coil. And that current can be fed into capacitors so that it can be ready for the next cycle. Now, you have to have fast switches to make sure the current doesn't flow back as the ion beam flows out of the coil, but that's possible. So that's one direct conversion approach. We get maybe a third of the energy out as X-rays, and we have a patented device based on the well-known photoelectric effect, and which is also explained in our video, that takes the energy in the X-ray photons and converts that to energy of electrons, which again are stored in capacitors at high voltage. So those are the two methods, both of them very compact and potentially very cheap, that we get the electricity out. Part of the electricity, of course, goes to the next pulse, and the surplus goes out to the grid. So we do this with only a little bit of energy each shot, but 200 times a second gives us the 5 megawatts.
I got two questions.
Well, all right. If they're quick.
Yeah, I got
give everybody a turn.
I'm living in Canada. I wanted to invest in WeFunder because I did some big investments a couple of years ago, but there's nothing to do for people in Canada. Is there some kind of solution? Because WeFunder doesn't allow people in Canada.
Can you use a VPN? Or does it check your license or something?
It would be violating Canadian law. That's the problem. Yeah, it's a terrible decision that the Canadian, I believe this is not the national government. I believe it's the province governments that have made this decision, correct?
I don't know. I live
I
in
think it
Colombia.
is. One by one, they've made this decision, and obviously we think it's a really bad decision. Supposedly they're protecting their citizens against fraud, but actually that means they're reserving all the good deals for people who are accredited investors. So all I can say is if, there are political organizations that advocate for the small investor, that, hopefully they'll get their point of view across. This was a big debate in the United States. I mean, the decision to actually make crowdfunding unlimited was made by a 3-2 decision by the SEC. So again, it really was a question of a debate within the financial community, whether this was going to help or hurt.
But in the immediate time, there's nothing I can do about it.
No, we don't know of anything, and WeFunder doesn't know anything, unfortunately. So it's a blow to us because, of course, Canada has given us a lot of investments.
Yeah.
Because, proximity, same language, and so on.
Yeah.
But
I
I'm
got a,
sorry.
I've got another question. If you look at the stock market, I was looking, I was reading through all your old agreements, and you mentioned something that you will go IPO as soon as the second phase of the whole thing is established, or if there's a prototype. But now you see also a small fission startup like Okla, who's being valued like $15 billion or something on the stock market. Is there maybe a possibility that you change it as soon as you've got net energy, that you go IPO? Because I think with the current situation, and might be a lot of money to be raised going to the stock market if there's net energy already.
Well, the problem with the IPO is that it is very expensive. I mean, as far as I know, and we have a good corporate lawyer, and he's never advised us that there's an easy way around this, is that if you're going public to raise money, you need an IPO, and that means you have to lay out a lot of money in fees for banks, who are the only ones who are authorized to do this process. So that's why we've always basically said we're going to do this once we become profitable. Now, it is possible we could become profitable at an earlier stage. Once we have net energy, we've always had the option that if a big player who wants to have a license with us wants to give us the money to help with development, they'll get a better deal, obviously, because they're absorbing the risk. We don't consider it a big risk that development won't be possible, even though we get net energy. So if we become profitable at an earlier time, yeah, then an IPO will be possible. But before we're profitable, A, we just won't have the money. And B, it would make the stock extremely speculative, which means that it could be manipulated by others to, bounce it down as well as up. So we wouldn't want to have that sort of risk.
Okay, we need to go to the next question, Eric.
Okay.
Thank you.
Thank you so much, Hubert. Okay.
Todd,
hi. Sorry for a long wait.
That's all right. Hi, thanks. This is a wonderful meeting. It's the first time that I've seen a meeting like this from you, and I think it's tremendous. And to hear that you're close to net positive energy is remarkable. But I want to suggest ways to get the word out a little bit more. I spent 42 years working in the nuclear fission industry power industry before I retired. And all the people that I know, when I've suggested or told them about LPPFusion, kind of look at me a little bit cross-eyed. And, I was used to hearing for that whole period of time, well, fusion is in the future, and it was always 20 to 50 years ahead. And it was that in 20 years later, it was still 20 to 50 years ahead. So it was kind of an ingrained skepticism. Sounds like you're closer. That's breaking. And this recent, I would call it bogus news with TAE, is another way to perhaps tap into more visibility. I think YouTube is great, but I'd like to be able to grab something, and I've tried with people who I know are scientific and engineering oriented in the fission industry, and they just don't seem to really latch on. And I think you have a good message. I think it really is a great message.
Yeah.
So when you said it's possible this year, you really got my attention. And if I can go and talk to people about that, there's really a hook, I think, now that you haven't had in the past. So I'm optimistic. This kind of a meeting is wonderful. I'm a scientific and engineering person oriented to that. I also wanted to put a little bit of my money toward put money where my mouth is. That's what I wanted to say. So that's why you have me. And I think it's really promising, and I wish you success. I mean, I think you're going to have success. I just hope that it's enough and funding is enough. Thanks
We
for
have
listening.
to thank you, Todd, for your comments. I've been really trying to get closer with nuclear fission people. I've, signed up for many nuclear fission groups, trying to teach people why nuclear energy is actually cleaner than solar and wind and so on. It's just hard to get the word out because I think neither nuclear or fusion actually have the marketing money to get the message out. We don't even have a Hollywood movie again depicting the fusion correctly. That's because we're struggling just for the research money, let alone the marketing and so on. So I appreciate your effort. Please leave the email so maybe we can help. Maybe you can help us fan some messages with your group of fission scientists. We do need their support. We are all nuclear after all.
Well, and if it would be helpful to talk about the various societies and all the different places that connect uh, radiation safety and nuclear engineering and
Yeah.
power people, I
I
would be
mean,
very
yes,
happy.
I would just inspire them right away by saying, hey, here is a nuclear fusion with zero nuclear waste. Who cannot love that? If
Well,
you're in nuclear fission industry and you don't like the nuclear waste problem, help over there.
no question. And there's no reason why those people wouldn't jump at that. But I just kind of get skepticism. And it's very hard to overcome that after so many years of hearing, in the future, in the future, in the
Well,
future.
I do want to put in a plug for the American Institute of Aeronautics and Astronautics is hosting, their Long Island chapter is hosting me at a forum on the fusion race, and that will be occurring, unfortunately, the day after our crowdfunding closes, but that'll be this Thursday, and all of you should have received invitations. That's going to, of course, be online. So that really is a good venue where these professional societies, technical professional societies, host us for their own members, which gives us a leg up in terms of credibility. So if that can be done for some of the nuclear energy engineering societies, that would be great.
I would throw out the Health Physics Society for you. There are people who
Yeah,
are
that's
very
true
interested
too.
in.
Yeah.
Uh,
Okay. Thanks,
Thank you,
Todd.
Todd.
Rodney?
Hello.
Hey.
I lost my internet connection on my computer, so I switched to my phone. I much rather prefer watching this on a computer, but I don't know what happened. I don't understand it. But anyway, the question I have is, can you elaborate on how the challenges that were presented by COVID and the pandemic, and how much you were your progress was slowed because of that? You would be much further ahead if it wasn't for that.
Well, certainly it was slowed. I mean, like everybody else, we had to close the lab. To a certain extent, we were able to do some work because we decided that Syed would go in by himself.
Mm-hmm.
So
Mm-hmm.
there would be no, um, danger of infection.
Okay.
Obviously it was a setback as it was. I mean, unfortunately, the damage done by the pandemic is still coming out. I mean, both in the medical damage, so many people with long COVID. My brother took years to recover from an extremely serious case, and this is multiplied by tens of millions. And it really hurt the connectivity of the entire society. So certainly it did slow us down. And the other thing I might add that is slowing us down is the general de-evolution of the industrial sector in the United States. I mean, we decided on what we needed to do for this new anode back in September, and here it is arriving in January. This is something where the machining probably would take, half hour, the annealing another half hour. This part has been sitting on two lines for months because there is no longer the capacity that this country used to have for dealing with high technology. So this is the other thing that is outside our control, as COVID was, is this disinvestment. We are, yeah, so definitely it has slowed us down. On the bright side, we're definitely moving faster this past year, and I think we've pretty much fully recovered from those delays. Next question. Thanks, Rodney.
Thanks.
Thank you.
Do we want one from YouTube if there's no hands up?
Yeah, I'm going through the questions. Let me see something earlier.
By the way, while Ivy's looking, I will comment that we definitely are going to try and do more of these events. This is our annual shareholders meeting, but it probably would be good to get these open public meetings done on a quarterly basis. We really do appreciate the input from all of you, and I think it is a good way to get us across. Okay.
There's a question by Bill Schwantz1. He was asking, do you have any plans to try for non-ignition fusion?
Well, let me explain what that question means. Ignition is a technical term in fusion for the point at which you are producing more energy from fusion than the plasma is losing. So that means that the fusion reaction starts to drive the temperature up. We do expect to reach ignition because we expect that with sufficient density, the temperatures we've already achieved with deuterium, and which we expect to match with hydrogen boron, of about 2.5 billion degrees, 250 keV, that should be enough to reach ignition and drive the temperatures up to about 6 billion, which is optimal. So at the moment, the answer is we don't think that we would have to look at non-ignition where, we're continuously pouring energy in and still getting at least net energy out. So at the moment, we don't see any reason why we shouldn't reach ignition.
Thomas is next, I believe.
Thomas?
So when you get to the point where we're ready to license out the technology for other people to do the manufacturing, you talked about the disinvestment in manufacturing. So are there companies, and what are they, that would have the capacity to manufacture reactors using our technology?
Well, certainly worldwide there are. I mean, most countries still have power generation that is basically public government. So, authorities like the Chinese Electricity Authority, the French Electricity Authority, those are big, deep-pocketed organizations that could mobilize industrial investment on a very quick basis. In the United States, yeah, I mean, it will be a political battle because you need something, you need a governmental entity to kick this off. If the federal government doesn't, and we hope that the political situation will change, a consortium of states might be able to do that. The government definitely can mobilize the resources. The moment the resources in the United States are basically concentrated in the aerospace defense industry. So some of those resources that are now producing jet fighters would definitely have to be reallocated to produce fusion generators. But the technological capabilities are still there. It's really the governmental will that's needed. Okay, yeah, thank you, Thomas.
Thomas, Philip Merillat is next.
Yes. There's no necessity of an IPO in any time. So could you speak to that alternative of considering at what time you might fund through licensing and internal revenue rather than in an IPO?
Well, I mean, an IPO has two purposes. One is obviously raising money, but the other is making the shares tradable so that all of you can achieve a financial reward and have an asset that is liquid. At the moment, your shares are not liquid. They can theoretically be sold to other investors, but as we've repeatedly said, we don't in any way guarantee that as a liquid source of liquidity in the present. So if we did decide, gee, we have enough capital from licensing and so on, we don't need more capital from the market. There is a financial route to marketing putting the shares on a general market without raising money. I frankly forget the name of that financial package, but it is possible. And then, of course, we would avoid the costs of the IPO if you're not raising money with you're just allowing the shares to trade that have already been sold to trade. And that does tend to be a cheaper option. So yeah, that could be a possibility if we've raised enough money through the licenses and so on to proceed.
Okay, let's go with Rodney Mills, and then we'll take Jose Choi's question.
Rodney, you had a second question?
Well, it's not so much a question. It's just that I know of someone, an acquaintance of mine, we're kind of like friends. He says he will not invest in anything, whether it's a company stock project or whatever, that he does not understand. And I've told him about your website. I told him, okay, there's a ton of information. There's a lot of videos. You can learn about it. And it's explained in such a way that someone who does not who's not a scientist, who doesn't know about fusion, it's explained in layman's terms, and not a lot of technical jargon. And so I don't know what else to tell.
Rodney, this is exactly why Hugh was talking earlier. He is writing the script just for people like that who maybe don't have scientific background. This is going to be funny, educational, it's going to be entertaining, it's going to be shareable. It's going to meet these people at the level where they are. So again, it's a challenge for our small team to make everything from the beginner explanation, introduction to the level that Eric is doing. So that is a challenge. Leave your email and we will send you the script. And then maybe you can start sending it to your friends so we can get some feedback perhaps.
Okay.
Yeah, I mean, it again comes back to what you was saying about the role of art. I mean, we're talking here about people's fear of not understanding something and being made to feel dumb if they don't understand it. That's part of the fear of mathematics, fear of science. It's really a big problem that's been created by the flaws in the educational system, especially in the United States, but to a lesser extent in other parts of the industrialized world. So, art addresses the emotions and links the emotions to information. I mean,
Mm-hmm.
you know, Star Wars, people have pointed out, is not exactly science fiction. It's more space opera or science fantasy. But, you can see the power of John Williams' music in,
Mm-hmm.
making this a cultural icon. I mean, I don't think
Mm.
Star Wars
Mm-hmm.
would have ever succeeded without that music. And,
Oh,
that's
yeah.
what art can do. I mean, we'd love to get a theme song. Maybe Ivy can compose one for us, or maybe somebody else. But that, bridging this gap between people's education, which is very light on science, and what we can convey, which they really can understand,
Mm-hmm.
that is the role of art in gathering up the emotions and saying,
Mm-hmm.
this is what you got to do.
I think sometimes there's a
Oh.
gap too, between like coming at it from this artist standpoint. Like I know artists in my life who are just skeptical about technology in general. And I think a lot of them have an idea of what, like the better world can be, and are trying to express towards that through their art. And they don't necessarily see this technology, like fusion technology, as something that can be a part of that story, of how we get there. And so I think connecting those dots will be a huge unlock for us and for people to be able to see technology as like a good thing that can make life better, and not as a thing that's just coming to replace us or take all of our jobs or be used to extract capital and make people rich.
Right. Okay, next question.
So there was this really technical question, but I don't know how you can answer that shortly. But basically, it was by Jose Choi. He says, "Can you explain how you envision the operation of the device in terms of the continuous plasmoid operation, given the much higher reaction temperatures required?"
Could you read the last part again?
Can you explain how you envision the operation of the device in terms of the continuous plasmoid operation, given the much higher reaction temperatures required? I know it doesn't.
Well, I'm not sure I understand the question, but
okay, let's go to
I
next.
think that what it is, I'll answer what I think it is, because it is an interesting point. The question is, this is a pulse device. The plasmoids exist only for billionths of a second, and the repetition rate is 200 times a second. So we pulse it, the device produces the energy, and then we wait until we pulse it again. So I think the question involves what happens to the device when all this energy is pulsing through it. Because, once we get to a generator, we're going to be releasing 5 megawatts of energy and a comparable amount of waste heat in a very little zone. So we know that this is one of the big challenges for the engineering phase, but we are doing a little preliminary research on handling these challenges. Rudy Frisch, our mechanical engineer, I don't know whether Rudy's here today, he started a preliminary study with a sophisticated simulation of the cooling of the anode, because the anode is at the center of the device and it's going to get the most heat flow through it. So we're starting to look at these things. Our preliminary answer is that by pushing existing cooling technology to the limit, we will be able to get that energy out and keep the device at a reasonable temperature. But we know that this is one of the challenges of the engineering phase. That's what we're going to be spending part of that money on.
There was a kind of related question in the YouTube from Jeffrey Dennison. which was about like how do you go
Oh,
about optimizing the anode design.
well, Jose Choi is in the
He is.
he is in the Zoom
But let's
meeting. Do you
continue
want to?
with okay, let's continue with Jose.
Okay, go ahead, Jose.
Hello. Can you hear me?
Yes.
Hi.
Yeah. Sorry. Good afternoon over there. I mean, I work in Saudi Arabia, for the only oil company in here, basically, for quite a while, and I've been interested for many years in LPPFusion. The main reason for this is my father is a quantum physicist. I didn't go for physics because in my childhood, being a physicist would pay very little. That was basically my motivation to get into engineering. But I always read about this issue because my dad studied in the Soviet Union, and he was very familiar. He was lectured by Landau and the likes, and back.
Really?
Yeah. He's the main joke in the family is the professors used to knock his door because he was always falling asleep. It was very cold for him. My dad is a Chinaman from essentially he was raised in Venezuela. My grandfather basically emigrated from China to the United States and then to Venezuela in the oil boom of the 30s. So, but anyway, apart from that, I mean, I have many questions. I just put a couple of there. I mean, it's true what you're saying. I mean, I understand that the device design is for a pulsating reaction that my understanding is that you are expecting to capture the X-rays and convert that into directly into electricity, which is a similar concept to Thai and 3 alpha and these guys that they also basically have a similar sort of proposition. I mean, I understand that, but following thermodynamics and all the rest of it, there is always a leakage. So I guess there would be some energy that would eventually get into the surroundings. And I mean, I work with cryogenics, basically helium separation and basically gas processing. We always struggle with thermal management, especially gasification processes of hydrocarbons into synthetic gas. And that's extremely challenging. I mean, you can have the device basically damaged in seconds. And I try to envisage how that happened. I mean, I read Walter, I believe, Walter Rowntree. I mean, nice to meet you. That you're planning some helium channels, but then you would need to have a helium system, basically recycling and recondensing helium to do that. The other question was the reaction. I mean, to me, is kind of it's the same with all these devices I've seen around. Is the reaction would generate helium, and you would have to put fresh diborane or tetraborane, one of those boron helium compounds. Um, but to me, it's hard to see how fuel would come on one side, no matter how small it would be, and the reaction products would go on the other side. I mean, I understand the boron helium reaction is quite attractive because it's aneotronic. But to me, it's a conceptual challenge. I mean, I see it in terms of chemistry and engineering. And I tried to do a couple of times to do the investment. The last one, I found that I'm not the only one struggling to basically make the payment to the system. So if you can just on a broad way to say how how you envision that, because I mean it's true the diborane or tetraborane will be there kind of thing, in the chamber, but you have to put fresh load every now and then, right? And you have to remove.
Well,
so
yeah, I mean, the two questions, as I say, with cooling, we're talking about compressed helium. We're not talking about supercooled helium. So we're not talking about a cryogenic. We're talking about compressed helium. The reason we're using helium is that helium will not, because it has a low charge on the nuclei, it won't absorb a lot of X-rays itself. So we're talking about cooling the beryllium to about 700 C. So the beryllium's still going to be warm, but at 700 C, it's not going to be evaporating. And the plasma in the background within the chamber as a whole will be about 2000 C, which is comparable to what you're looking at in a jet engine. So it's at the outer envelope of present day technology, but we don't think it'll be beyond. But we're not going to have anything cryogenic. So that's one point. And we do envision leaking the fuel in continuously as a gas into the chamber. And the helium will be coming out in the beam. So after the beam is slowed down, the helium will be located at the end of the drift tube and will just be accumulated and gradually leaked out. Obviously, we're not going to be producing a lot of helium because we're only, a machine will use 5 kilograms of fuel in a year. So each machine will be just producing a little helium. So that's what's going to be happening. But
Yeah,
the fuel will be leaked in
we gotta
continuously.
move. It's been an hour and a half, so let's wrap up. We have
Okay, well,
Rodney.
any last
we have
urgent questions?
Yes, we have Rodney and Philip, and that's about it.
Okay, we'll take Rodney and Philip quick questions and then we'll sign off.
Okay, it's not a question. It's I just wanted to say that since I invested in LPPFusion in 2019, I believe, I've talked to several people and I tell them I invested in LPPFusion. And of course, they don't know about your company. And they ask, what's that? What do they do? And I didn't know what to tell them. And I would tell them, well, they do this. And after maybe 2 or 3 minutes, they've lost interest or whatever. So now I have my 30-second elevator pitch. I can tell them it's nuclear power without nuclear waste.
Do not mention nuclear. Everybody runs for the hill. Even politicians agreed to just call it fusion, especially in our aneutronic fusion case, which again means no nuclear waste. So what you want to tell them is that they're making a fusion generator, which can produce millions of times more energy than oil or gas with zero nuclear waste and zero pollution. That's 20 cents.
And for a tenth of the cost.
The benefits of fusion is where the real beauty is. So the money saved on the oil, on the pollution we get from, the air and the oil spills and whatnot, the medical expenses for, all kinds of problems from pollution. That in itself can save us trillions of dollars that currently go to oil subsidies. And the trillions of dollars could be repurposed for everything we want: cheap rent, cheap housing, cheap schooling, cheap healthcare. That's the pitch.
Or another very short pitch, which I use when people ask me, what do I do? Is, well, this is a company that's going to, if it succeeds, it'll drive oil and gas companies out of business with cheap, clean, safe, unlimited, decentralized energy, which is less than 30 seconds. Okay. Last question, because we need to wind up. Philip.
Could you tell us about your patents and some prospective ones, future?
Well, we don't want to tell people what those patents are because we haven't patented them yet. But we are working right now on 2 patents applications. Um, Again, we need money. We're going, the patents take a lot of fees. Um, Over their lifetime, they take $150,000. Fortunately, not all of that is up front. But given good funding, we should get 2 patent applications in, maybe 3 this year. So that's a good place to wind up because if people want to help us get those patents or help our research along, please do, if you haven't already, invest in this round. The round does end at the end of the day on Wednesday, I believe Pacific time. Uh, so if you have any money available, do help us. And thanks a lot for everybody for coming and for your
Wait, one last thing.
questions.
One last thing.
Yes, Ivy.
Warwick suggested, before we wrap up, maybe quickly address Jeffrey's question, which Sam raised earlier. Warwick or Sam, what was this question by Jeffrey?
Jeff?
I was just about how do you iterate on the anode design, and I guess on the machine design
Oh, okay.
in general. Trial and error.
Well, that's a long question. Let me see whether a short answer.
I can do the short
basically,
answer.
you got to read our reports because we do report on
Okay,
everything we do.
basically, we fight about it in the lab, so nobody can see that part for about 20 minutes every time we get together. And then we regroup. And then after a month or so, usually Eric wins the argument. However, there is a new way of making these anodes, so they don't make them from the one piece anymore. Now we signed up for the one made of the dust. So we have to talk to manufacturer to see could they really reuse the old anode and dust it. We don't know. This is a whole new thing.
Well, we do know that we can make the anode stronger out of a stronger material. In other words, this is still beryllium, but it's made in a way, all beryllium is made from beryllium powder, but it's pressed together in a stronger way with less voids. So we do know that we're going to get a stronger anode in the near future. But, the basic way all science research is done, including ours, is we do experiments, we make observations, compare observations with theory, and take into account new processes. We try to understand what processes are going on and change our design, what we do, our procedures, how we run the machine in accord with our understanding of the new processes that we've discovered by observation. It's basically the same cycle for everything. So again, I thank you all, and hopefully we'll be doing this again in a few months. And do get your investments in. Reg D, by the way, does end at the same time. So this will be the last time we will be selling shares either way at this price. And then later in the year, we'll resume at a different price, higher. Okay, thank you very much. Martin, you can wind up.
Thanks, everyone. Hope to see you soon.
Okay, thank you.
Bye.
Bye.
Thanks, Walter, Sam, you.
Thank you, Walter. Nice meeting you finally.